In Part 1, we learned that process safety incidents are usually part of a chain of events. To prevent them, we put a series of controls or barriers in place. We can represent this with what we call the bow tie. It's a diagram which shows possible threats and the associated barriers on the left side, with the unwanted event in the middle, and all the possible consequences with the safety barriers designed to contain the incident, such as detection and emergency response, on the right side. There's one story that brings a bow tie to life perfectly. It's about a seemingly ordinary valve that wasn't quite right. And then one ordinary day, when a worker closed another nearby valve, a chain of decisions and actions made by a number of people led to that explosion, even though a series of barriers intended to prevent it were in place. Design barriers, inspection and testing barriers, operational barriers, all failed. The story starts with an automatic shutdown valve that needed to be replaced. A buyer in contracting and procurement ordered the valve from a recently approved new supplier. The vendor did not have a valve that perfectly matched the old one, and the purchaser chose a similar valve without noticing it had a slightly different material specification. The purchaser did not confirm with the engineer whether the valve was suitable for his requirements. It was a small mistake, an oversight, but one that will have far-reaching consequences. The new valve was purchased, delivered, and then installed. Nobody knew that the valve was different. Because it was from a new vendor, it didn't appear in the database, and the team installing it assumed the right valve was delivered to site. Those decisions meant that the design and construction barrier had failed, but no one knew that. The valve was in place, and it worked fine. But because it was made from slightly different materials, corrosion triggered by the fluids in the pipe caused it to start degrading internally, where no one could see it. There was an inspection program to monitor the wall thickness of the system where the valve was installed. However, it only checks the pipes and not the valves because they are manufactured with thicker walls. The automatic shutdown valve was also tested regularly, but routine testing would not identify the valve was gradually being degraded. So the important inspection and testing barriers did not identify the developing corrosion. The next barrier intended to protect us from an incident was an operational one. Normally, all the valves on this system are never closed at the same time to avoid the risk of increasing the pressure to a level that would trigger a pressure relief valve. All operators are trained and tested to make sure they know that. But on this day, a trainee operator was asked to isolate one part of the facility, let's call it System A, in preparation for maintenance. However, System A is identical to and located right next to System B, which contains the badly corroded valve. The fact that he was a trainee shouldn't cause problems, because during critical operations, a supervisor always accompanies an operator under training to prevent mistakes. But the supervisor wasn't accompanying the new operator. He was in the office, dealing with an overflowing inbox. He'd clearly explained that the valve that needed to be closed was on System A, but the new operator got confused and didn't feel he could stop work to go and check. So he closed the wrong valve on System B. The system pressure built up quickly, and the corroded valve started to leak. The incident very nearly ended in tragedy. Luckily, a gas detector picked up the leak and initiated the alarm. The operator and everyone else in the area got clear just before the gas plume ignited. No one was hurt, but it could have been very different. A series of barriers failed to stop a wrong valve being purchased, installed, and put into operation. Luckily, one barrier, the gas detection system and the emergency response procedures, on the right-hand side of the bow tie, proved to be robust. This incident shows that a number of barriers can fail one after the other if the people responsible for them don't own them and prove that they are working. So own your barrier. The owner of the gas detection barrier saved lives that day.